Alright, so heat and work. Alright, so E is what? Internal energy. It is a sum of kinetic energy and potential energy of all particles in the system. That's internal energy. Okay. Now sign reflects. Now whenever exothermic, the heat, when we talk about heat, alright, if it is endothermic, Q is what? Positive. If it is exothermic, Q is negative, because heat is. Now whenever the internal system does work, okay, so when the work sign is positive or negative, so let's say the system does work on surrounding, and that time we can say W is negative, and on the other side surroundings work on system, in that case W is positive. So in thermodynamics, signs are very important. Okay. Now let's work on, let's see if I can find a couple of problems that we can solve mathematically.
What's the VE? Wait, Q is positive, VE.
It's a positive. Let me write down. Q is positive. It's a positive. And it's negative. That helps?
Yes.
Okay, so we are talking about signs, okay? Alright. Now let's work on problem. And remember, we also define if it is P delta V I, right? So now let's work on a problem. Okay? We are going to work on one of the problems. A certain gas expands in volume from 2 liter to 6 liter at constant temperature. Calculate the work done by the gas if it expands. The first one is against a vacuum, and second one is against a constant pressure of 1.2 atmosphere. Okay. Now first, we know that work done on a system. So I'm going to sketch a little situation, and that way it's from 2 liter to 6 liter at constant temperature. And what we need to find? We need to calculate work done, right? We know that W equals negative P delta V, right? So I'm going to sketch this problem, and then we'll see how we can solve this problem against a vacuum and against a constant pressure of 1.2 atmosphere. So let's go next page. We have, let's say, this initial is 2 liter, and this is opposing pressure, and this is initial condition. Now what's going to be happen next one? And then pressure, that's the final. For A, we have vacuum, so P equals 0, right? We need to find for A. For B, pressure is 1.2 atmosphere. So when you find delta V, which is 6 minus 2 liter, which is 4.0 liter. Alright. So work done in a gas expansion is equal to the product of external. Okay, so we know that W equals minus PV, P delta V. So first we will work on under the vacuum, minus P delta V. We have 0 pressure because it's under vacuum, and 6 minus 2 liter, so we get 0. Work done. But how about for this condition? For B, under this condition, we know W equals minus P delta V, which is negative 1.2 atmosphere, and volume we have 4 liter. So we get negative 4.8 liter times atmosphere. Now we need to convert into joules. Let's say if we need to convert into joules, what we do. I'm going to go to next slide. So we can write W equals negative 4.8 liter times atmosphere, and then we know that 1 liter atmosphere, then 101.3 joules. In that case, liter atmosphere cancels, and you get work done is negative 4.9, 10 raised to 2 joules. That's due to gas expansion. So you can calculate. Now we are going to work on one more problem.
I go one slide back, please?
Yes. Okay. We'll go to one more problem on thermodynamics first law. Any questions?